Hey guys, we're back with the notes for 4.6. We're going to be writing parallel and perpendicular lines, okay? Go ahead and pause the screen, write what you see, and then we'll get started talking. Perfect. So at this point, you should have written down everything on the screen. We want to compare parallel lines and perpendicular lines, but I want to preface, not every set of lines qualifies as one of those. You are going to have a category, we're going to talk about that in just a second at the bottom, where it is going to be neither, and that's okay. So parallel lines are like railroad tracks. They never cross. Think about it like people doing a dance at a wedding or at a school dance. If you're doing the cha-cha slide or the Cupid shuffle or the wobble, people don't run into each other because they're moving the same way. That same idea happens for slope. If I'm rising and running the exact same amount, then I'm not going to run into the other line. So same slope is what makes parallel lines. Okay? Moving to perpendicular, equations that have slopes that are flipped and with different signs make perpendicular lines. They're not just lines that cross. They have to cross to make this perfect right angle. Let me zoom in real quick. It has to make a perfect right angle or a 90 degrees right here. Okay? So in order to do that, my numbers have to be flipped. 2/3 turns into 3/2. And they have to be signs. So one has to be a positive slope, one has to be a negative slope. Okay? All right, once you have that idea, let's talk about neither. So there are lots of options for equations, like this one, where I'm going to have, they might be flipped, but they're both positive. Or maybe one's positive, one's negative, but they're not flipped. Not every set of lines has to be parallel or perpendicular. It is possible to be neither. Okay? Write that down. I'll meet you on the next page. Okay. So on this page, I went ahead and highlighted all of our slopes. Here's what you're going to do. We're going to try and classify them into parallel, perpendicular, or neither based on the rules we just saw. There are going to be 4 parallel answers, 4 perpendicular, and 3 that are neither. So let's get started. On problem 1, we're in point slope formula. My slopes are 2 and 2. That would make them parallel because they have the exact same slope. So number 1 would be parallel. Number 2, my slopes are a -1 and a 2. They're not flipped. They're just one positive, one negative. That makes them neither. Number 2 should be neither. Number 3, I have a 2/3 and a 3/2. Those problems are flipped, and they're also one positive, one negative. So number 3 should be perpendicular. Okay? Hopefully you kind of get an idea of what we're doing at this point. Number 4, my slopes are 1/5 and -1/5. They're one positive, one negative, but their fractions are not flipped upside down. So that makes them neither. Problem 4 is a neither. Number 5, my slopes are -7 and -7. They have the exact same slope. That makes number 5 parallel. Go ahead and write number 5 under parallel. Moving on to number 6. Number 6 is -1 and +1. This one's tricky. I want to look at this. If we were going to write this slope out as a slope, rise over run, we would say -1/1 and +1/1. Notice that this fraction is flipped, and we have one positive, one negative number. So, in fact, if I was to graph these, they would come out to be perpendicular. Number 6 is perpendicular. Number 7, we have -6/11 and 11/6. Notice my fractions are flipped. I have one positive, one negative. Number 7 is also perpendicular. We're almost done with that column. Number 8, I have 4, which remember we can write as 4/1, and 1/4. So I notice they're flipped, but they're not perpendicular. Why are they not perpendicular? Hopefully you're thinking because 1's not negative. So in this case, it's a trick. That is neither. Number 8 is neither. All right, last 3 questions. Number 9, we have slope of 3/4 and 3/4. Those problems are exactly the same. That makes them parallel. Number 9 is parallel. Number 10, we have 2/7 and -7/2. One positive, one negative, and the fractions are flipped. Number 10 should be perpendicular. Number 11, my slopes are 3 and 3. They are both exactly the same, so 11 is parallel. Go ahead and write 11 under parallel. When you have all of these written down, go ahead and move to the next page. All right, I'm going to ask you to pause on the screen. Go ahead and set up problems 1, 2, 3, and 4 all the same way. Leave yourself some room to write. And go ahead and write steps 1, 2, and 3. Press play when you're ready. All right, let's go ahead and look at this. Nothing is changing from 4.5. We're still writing an equation. The only difference is now I get to choose my slope based on what my goal is. So in problem 1, my goal is to be parallel to 3x plus 2. If I want to be parallel, I want to have the same slope as him. So I am also going to use a slope of 3. I don't care about the 2. It doesn't matter. I'll even scratch it out. We don't need that. But I do need my 1 and 4. Those are going to be my points. So I'm setting it up. Y minus 4 equals 3, x minus 1. I'm plugging in my x and my y along with the m that I chose. I'm going to distribute that 3. That gives me 3x minus 3 because I'm multiplying and distributing it out. My last step is to cancel. I'm going to cancel off that 4 by adding 4 to both sides. My final answer will say y equals 3x plus 1. We are done with problem 1. All right, I'm scrolling down. Let's go ahead and look at problem 2. Problem 2, I want to be perpendicular to negative 4/3 x minus 2. I don't care about the minus 2. I only care about the slope. To be perpendicular, I need to flip it and change the sign to a positive. So that's the slope I'm using. I'm going to take my point, negative 4, 0, and plug it in. Y minus 0 equals 3 over 4, x minus a negative 4. Remember that when you have two signs, let me change colors real quick. When you have two signs like this, we want to make it a big old plus sign. So I'm going to put a plus over that. Now we can multiply. So 3/4 times x makes 3/4 x. 3/4 times 4 makes 3. I do not need to bring down my 0. All I need is my y. So that right there is my final answer. I'm done. All right, we're moving on to number 3. Remember, you can pause it anytime, go back, rewind, and listen to it again if you need to. All right, problem number 3. I want to be parallel to negative 1/2 x minus 1. I don't need the negative 1. I only care about the slope. I want to be parallel, which means my slope is the same. I'm going to use negative 1/2 also. I'm plugging in negative 6/5 as my point, so it's going to look like y minus 5 equals negative 1/2 x minus a negative 6. Again, I have those double symbols, so I want to make sure that I change it to a plus sign. Once we do that, we're ready to multiply. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times 6 is a negative 3. Again, you would use that in the calculator if you were in class. We need to cancel off the minus 5, and I'm going to add 5 to both sides. I know it's tight on space. Try and fit it on there. When my 5's cancel, I have my answer. Y equals negative 1/2 x plus 2. When you're done writing that down, we're going to go back up to number 4. Last one that has work. So problem 4, I want to be perpendicular to 3 over 7x plus 2. I don't need the 2, I just need the 3 over 7. If I want to be perpendicular, I need to flip the fraction and change it to a negative. I'm going to use 9 and negative 15 to plug in my point. So y minus negative 15 equals a negative 7 over 3, x minus 9. I have another double negative, but it's not in the same place. This time it's with the y. So I'm going to go ahead and change that into a plus sign. Now I'm ready to multiply. I'm going to multiply negative 7 over 3 times x. Gives me negative 7/3 x. I'm going to multiply negative 7 over 3 times a negative 9. That gives me a positive 21. We're going to bring down what we have. Last step is I need to cancel off that 15. I'm going to subtract 15 from both sides. And when the 15s cancel, I have my answer. Negative 7 over 3x plus 6. And we are done with number 4. I'm going to ask you to look at 5, 6, 7, and 8 very carefully because all of these have very little space on them. These are going to be my shortcuts. I want to remind you that parallel means that you want them to be the same. So on the problems that say parallel, I'm going to write out same. I want to remind you that perpendicular means you want the opposite. So under the ones that say perpendicular, I'm going to write out opposite. The reason these are shortcuts is because they're y equals a number or x equals a number. You do not have an mx plus b going on here. Okay, so if I want to be parallel to a y equals, that's a horizontal line. I want another horizontal line, which means I want another y equals. All I have to do is keep the same kind of equation and take the y number. My y is 5. Problem number 6 is different though. I want to be perpendicular to y equals. So I don't want to be the same y equals. I want to be the opposite of that. I want to change to an x equals. And what does my x equal? 3. Those are my answers. Okay? Parallel means use the same. Perpendicular would mean change it and go to the other one. Okay? All right, let's look at number 7 and 8. Number 7, I want to be parallel to an x equals 7. That means I want to use the same kind, a same as an x equals. My x is 2. So my answer is x equals 2. Problem number 8, I want to be perpendicular to an x equals 1, a negative 1. So my equation isn't going to be x, it's going to be a y equals. And what does my y equal? Well, my y equals 9. I'm going to zoom out. You can write down anything you need to. Your assignment is going to be page 135, 136, numbers 1 to 10. Heads up that numbers 7 and 8 are going to be a little bit tricky. Come see me if you have any issues. Otherwise, your test is the next day.